Dear student, welcome to the online learning. Today we are going to learn about chapter number 5, that is understanding elementary shapes. Today's topic will be polygons. So let's begin with our today's learning here, children. So let's learn what are polygons. So children, if you find any figure, they are simple closed curve and made up of entirely of line segments, then we call them as a polygon. And the line segment which are used to form such a polygon, so that are called at its sides. Okay, see here the figures we have taken as an example. So you can see here we have obtain a closed curve formed, and this closed curve is entirely made up of line segments, so we say that this is a polygon. In the same way, see here the next figure. You can see this figure is a closed curve but not made up of line segments, so that's what they are not a polygon. In the same way, look at this third figure also. Here also they are forming a closed curve but not made of entirely line segments, so not a polygon we say it. And then see here one more figure, it is a polygon. Why so? Because you can see that this figure is made by entirely joining number of line segments, and by doing so we have got a closed curve formed. Now come to the classification of polygons, children. So here we have a classification on the basis of number of sides they have. Okay, so if we talk about three number of sides, okay, so when we take three number of line segments and by joining them in such a manner that we get a simple closed curve formed, so that particular polygon we name it as a triangle. In the same way, if we take four number of line segments and we after joining get a simple closed curve formed, then that particular polygon we name it as a quadrilateral. Okay, and it has four number of sides. If we have five number of total line segments and by joining them we get a simple closed curve formed, okay, so then we name it as a pentagon. Now in the same way, if we have six number of total line segment used and by joining them we get a simple closed curve form, then we call it as a hexagon. In the same way, children, if you talk about this seven number of line segments which will be used and by joining them if we get a simple closed curve formed, okay, so we call them as a heptagon or a septagon we can say. Likewise, if you talk about octagon, so here we join total 8 number of line segments in such a manner and we get a simple closed curve form, then we call them as a octagon, and here we have total 8 number of sides used. Okay, now come to the exercise question given in textbook page number 108. So children, we have to state whether the following given figure they are polygon or not. If not, then we have to tell them why. Okay, so you look at this first figure, you can see they are made up of line segment, but you can see they are not forming a closed curve. Okay, because you can see here one opening end and here also one opening end, so we can say that it is not a polygon as it is not a closed figure. In the same way, look at the second figure. Okay, so what we can say about this figure? Yes, it is a polygon because it is a closed figure made of line segments. So how many line segments you can see here? We have used here total 6 number of line segments and we got a closed curve formed. Then you see the C1 figure, same way you can say it is not a polygon. Why? Because it is not made of line segments. Okay, now look at this another figure D1. Here also you can say, children, that it is not a polygon because it is not made of only line segments. Okay, here you can see they are not only made up of line segment, we have a curve also, but we require such a figure, okay, such a closed figure which will be entirely made up of line segment. Now come to the third question where we have to draw a rough sketch of a regular hexagon. We have to connect then three of its vertices and we have to get a triangle, and then we need to identify the type of that triangle. Okay, so let's do this question. So here we have drawn a regular hexagon. I think you have understood. We have taken here total 6 number of line segments and we have joined them. Okay, so we will be naming them as A, B, C, D, E and F. Okay, so here we have drawn a hexagon naming them as a B, C, D, E, F, and now we have to connect its three vertices. So children, you can see when two of its edges meet at a point, that particular point we call it as a vertex. So here we will be joining vertex A, vertex B with vertex F. Okay, so let us do this. So you can see vertex A, vertex B and vertex F. So by joining this vertex we will be drawing such a triangle. Now we need to identify this triangle which is obtained by joining ABF. Okay, so you can see this AB is equals to AF, whereas they are different than BF length. Okay, so we can say that they are the isosceles triangles. Okay, so here by joining the vertex ABF we have got a triangle formed. We can say it as ABF is an isosceles triangle. Now come to the classification of triangles, children. So we can classify the triangles on the basis of its sides as well as on the basis of its angle. So let's first discuss about the triangles classification on the basis of its sides. So children, look at this three-sided closed figure, and all of its side they have the same length, that is 3 centimeters. So we call such type of triangle as an equilateral triangle. In the same way, look at this another three-sided figure. Okay, so let's see what are the measure of these three sides. You can see here the first two sides, they are of 2.5 centimeter, and the third side here it is of 4 centimeters. So we such type of triangle where we have two sides of equal measure and one sides of different measure, then we call such triangle as an isosceles triangle. In the same way, you look at here the third figure present in the screen. Okay, so first side is 4 centimeter, another is 7, and the third side is of 6 centimeters. So such a triangle where all of its sides are of different measure, then we call such a triangle as scalene triangle. Now you see here we have here the classification of triangles on the basis of its angle. Now, so children, look at this first triangle, and you see here the angles formed inside of this triangle. Okay, so you can see the angles whatever is formed inside this triangle, they are less than 90 degrees. So such a triangle we call it as an acute angle triangle. In the same way, look at this next triangle drawn. So if you see, it's one of the angle. Okay, as we know, triangle is a closed curve or a three-sided polygon where we have three vertices, three angles and three sides. So if you see here, it's one of the angle. So here we have one of its angle equals to 90 degree and rest other two angles are of less than 90 degree. Okay, so if you have one of its angle equals to 90 degrees, such a triangle we name it as right angle triangle. In the same way, look at this third figure. Here one of its angle is more than 90 degree. Okay, that is 130 degree, but it is less than 180 degree measure. So such a triangle we call it as an obtuse angle triangle. Okay, now come to the exercise question. We have to name the types of following triangles. So children, if the triangle is having a length of 7 centimeter, 8 centimeter and 9 centimeters, so this, you know, if we have all different three sides, then in measurement, so we call them as a scalene triangle. In the same way, if we have a triangle PQR and PQ is equals to QR and is equals to PR, means all the three sides are of 5 centimeters. So such a triangle we will be naming it as a equilateral triangle. In the same way, see here the next question. Here one of its angle y is 90 degree and xy is equals to yz. So you can see two of its sides are of same length in measure and one of its angle is 90 degree. So we call such a triangle as right angled isosceles triangle. Okay, now come to the third question. We have to name each of the following triangles in two different ways. So see here again, the outer length you can see they are of all measurements are mentioned. So two of its sides are of 5 centimeter, one is different, that is 8 centimeter, but the three angles inside it, they are of less than 90 degree. So we can name it as acute angled and isosceles triangle. Okay, in the same way, see here the another figure. You can see all the three sides are of different measure, but one of its angle having the measurement equals to 90 degrees. So such a triangle we can name it as right angled and scalene triangle. In the same way, see here the third figure. Two sides are of same measure and the angle formed inside it represents 90 degree. Okay, so one of its angle is 90 degree, so we can say it as right angled isosceles triangle. Now let us discuss about the classification of quadrilaterals also, children. So here we have the first quadrilateral. As you know, quadrilaterals, they are the polygon which will be formed by joining the four number of line segments. Okay, we get a closed curve formed, okay, by joining the four number of line segments. So here we have joined line segment PQ with QR, and that too with RS, and then with SP. So here you can see in this figure we have four right angles formed, okay, as well as you can see that PQ is equal with SR, and QR is equal in measurement with PS, okay, as well as you can see PQ is parallel with SR, as well as QR is parallel with PS. Fine. So these are the properties you can see. And now come to the next quadrilateral, that is a square. So here also we have joined the four line segments and we have got a closed figure form. So here in this square, if you talk about, we have all four equal sides, okay, and as well as four right angles are formed in this quadrilateral. So this quadrilateral, we name it as a square. So now let us see what all things are equal. So if you talk about angle M, it is equals to angle O, and that is equals to angle R, and this angle is equals to angle E, and all of them, they are equals to 90 degree in measure. In the same way, if you talk about its length, MO is equals to OR, OR is equals to RE, and this is equals to EM. Fine. So all the four sides are of equal measure here. Now see here the next quadrilateral, that is a parallelogram. Why we say it as a parallelogram, let us understand this thing also, children. So you can see we have drawn here parallelogram LMON, okay. So here we have two pairs of parallel sides. Now let's see what are they. So if you talk about this side LM, it is getting parallel with the side NO. In the same way, if you talk about this side MO, this is getting parallel with LN, okay. So that's what we name it as a parallelogram here. Now come to the further classification of this quadrilateral. If you see, we have here the few more quadrilaterals, okay. So that is rhombus. So now let us know about rhombus also. So here in this quadrilateral, opposite sides are parallel, okay. That is GJ is parallel with HI, and GH is parallel with IJ, okay, this we can say. And here the measurement of the lengths are of equal if you talk about all of its four sides, as well as the angle formed at four of its vertices will be of equal, okay, measure. If you see here angle G, it will be equal in measure with this angle I. In the same way, if you talk about this angle H, so that angle H will be equals to the angle J, okay. So rhombus is what? A quadrilateral in which opposite sides are parallel and opposite angles are equal, okay. This opposite angle opposite to G will be angle I, so they both will be of equal measure. Same way, angle opposite to angle H will be angle J, so they both will be of equal measure, but all the four sides, they will be of equal measure, and the opposite sides will be parallel, like GH will be parallel to IJ and HI will be parallel to GJ. Clear? Now see here the next quadrilateral, that is trapezium, okay. So here one pair of opposite sides, they are parallel, like TU, you can see it is getting parallel with WV. Fine. Now come to the last quadrilateral, that is kite. So here you can see, children, two pairs of adjacent sides will be equal in length, okay. So adjacent side, if you talk, so RD is getting adjacent with RO side, so they will be of equal measure. In the same way, if you talk about the another adjacent side, so it is AD, and with it the adjacent side is AO, so they are of equal measure. In the same way, let us talk about the exercise question given in page number 106. So we have to tell this true or false for the given statement. So each angle of a rectangle is a 90 degree, means it is a right angle. So what you say? It is a true. Then come to the next statement, the opposite sides of a rectangle are equal in length. So this is also true, okay, that we have discussed right now only. Now come to the third question. The opposite sides of a trapezium are parallel. So just now we have discussed, we don't have the opposite sides of a trapezium as a parallel. We have only one pair of opposite sides as a parallel. Okay, only one pair of opposite sides are parallel in trapezium, so it is false. So I hope whatever we learned today you have understood, children. Complete your home assignment. Thank you.